Yeah, we'll start in a sec. I'll just testing this sound and everything. See if it's working. Yeah, there is a bit of a delay. When I say a delay, it's not too long. It's about 6, 7, 7, 8 seconds or so. Something like that. 8, 9. Okay, I'll share a invite for the stream just in case someone wants to join in. Most of our traffic is actually on LinkedIn, surprisingly, and not on YouTube. But LinkedIn's a bit, yeah, probably shouldn't say anything. Get kicked out of the platform, wouldn't I? Okay, just bear with me. Bear with me. We can do a disclaimer in the meantime. We can do a disclaimer. We can use OpenAI FM. Ballad or choral? Let's do choral. Dramatic? No, let's do medieval night. Medieval night. Let's see how that goes.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it is important to understand that Bionic Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information, and that unfortunately includes even the worst-case scenario of data loss. So, while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, bionichaos.com. Definitely check it out when you have a moment, and I'd love to hear what you think. There is a human in the loop, so please be patient and wait for the human to respond.
That's right. There is a human in the loop. Just about. Yeah, there's quite a bit of a delay. There is quite a bit of a delay. But we can manage, can we? We can manage. I don't know, it's a bit longer than usual. It's like 8, 9, 10 seconds maybe. I'm not dropping any frames. Oh, wait a sec. I know what's happening. I'm processing this video. So we actually have this a Python code. Yes, everything we do is either automated with generative bots. Whatever is not automated with generative bots is automated with algorithms. So yeah, again, it's a full disclaimer. When we finish a live stream, well, we currently have a huge backlog, but eventually we are processing. Currently, we're processing a live stream from about a month ago, and we have this the Python code using these libraries, JSON rare, whatever that is, for progress bar. Well, JSON is JSON. It's not adding. Anyhow, yeah, using this libraries to actually remove the silence from the video. It's using Librosa. Librosa. Yeah, one of those video and audio libraries, and it's going through a very long video, chopping it up into pieces and removing audio that is below a certain threshold. Actually, we can give it to the new CTO that we have to check if there is anything potentially wrong with the code or anything that we could improve. Should we do a canvas? Not sure how to work. It's just a bit confusing because it's different to what we got used to with ChatGPT. ChatGPT used to be a CEO / CTO, but they, or CDO, but it was Chief Data Officer, but they stepped down into part-time, still have into a part-time position. We still have access to it. We actually were using it to generate images because the Gemini image generation model is not as good as Sora, or I'm not sure if it's just me, got used to, the OpenAI stuff. I'm not sure. Let's pop this code. Let's not do any prompting, see what it says. Can we do it without any prompting, maybe? Okay, we have new tools and blocks coming out. We'll talk about it in a sec. We have this ECG signal simulator. Actually need a title and everything. And yes, on a smaller screen, it will just show 3 ECG channels. If your screen is bigger, yeah, it's not ideal. It will show you the whole 12 leads. So it will switch between 3 leads and 12 leads. You can do it manually yourself. And we are simulating different ECG conditions. This one is, I'll try to pronounce it, I'll probably fail miserably, but this one is trying to simulate the ventricular tachycardia. How did I go? Do I have any ECG fanboys or girls or non-binary in the room? Do let me know what you think. Acute STEMI. Yeah, we have to go over all of those, see, how good they are. See how good they are. see how good they are. But I'm still testing it, and we have two professional podcasters now available. They are shall we let the professionals do the job of describing this page? How does that sound? And we will add that podcast as audio to the page itself. I think we downloaded it. Let me check. No, I don't think we did. Let's download the audio. It's only 43 megabytes. That's fine. We can deal. We can deal with that. Let's actually play it in a separate window because
Welcome to the deep dive.
Well, because in Notebook LM you cannot generate multiple chats. So if we adding sources and we cannot regenerate, we can only download, delete, change playback speed, which we can do in VLC as well. So let's use VLC for that, and I'll be adding that audio to the page. So there will be a player somewhere on the page for you to listen.
Today, we're plunging into some source material all about a pretty interesting tool, an ECG simulator.
Yes, exactly. A piece of software basically designed to generate synthetic electrocardiogram waveforms.
Right. So our mission here is to slice through these sources, pull out the most important nuggets, and really figure out what this simulator is, what it does, and maybe why it matters to you, the listener, especially if you're learning this stuff. At first glance, it sounds pretty straightforward, digital heart machine. But our sources immediately show there's a bit more to it. It's a powerful tool, seems packed with features.
And it's wrapped in a disclaimer you absolutely cannot ignore. That's key.
Yeah, that disclaimer jumps right out. It feels like the difference between understanding a clean model and, well, knowing the messy reality it's supposed to represent.
And the sources really hammer that distinction home. Crystal clear.
Exactly. But,
Yeah.
okay, the basic idea of being able to, fiddle with
Disclaimers are very important. We're adding a bunch of disclaimers just in case I don't want to get sued. In the Notebook LM itself, you can actually do interactive mode and actually ask questions and stuff. Problem is, it does not modify the audio file when you export it. So if we want to actually modify the output, we actually have to interact with we actually have to add more sources, remove sources, so on and so forth. Or chat with the thing. It doesn't actually say what model it's using. It has different controls. Conversational style. Can do custom PhD level. Yes, we want. We want a PhD level, but we're also on YouTube, so we want every level. Suggest different roles. Yes, choose. Yeah, and you can do the same. No, wait. Blah blah blah. Did we? No. Yeah. So we'll leave it default for now, and same for the podcast. You can change. Have custom prompts there as well.
virtual heartbeats.
Yeah.
That's inherently interesting. So let's explore how this thing is built and what kind of virtual cardiology you can actually perform.
Sure. So the core concept is generating that ECG, tracing the electrical activity of the heart, but doing it computationally, synthetically.
So not recording a real heart, it's creating the waveform based on parameters you set.
Precisely. And the way you interact with it, according to the sources, seems quite flexible. It offers different levels of complexity.
Yeah, that seems like a really key design choice. It starts with a basic mode,
Yeah.
Simplifies the controls.
Right.
Then if you want a bit more granularity, you can switch to intermediate.
Okay.
And for those who really want to get into the weeds of specific patterns, there's an expert mode.
So it kind of scales with your knowledge or curiosity.
Exactly.
So let me jump in. Yes, we have originally we had those basic controls. It's mainly was there to do with the fact that we're trying to optimize for mobile as well. So on mobile, you probably will only have the basic, and then you can show the intermediate and the expert controls as well. So that's just how it works. That's what our professional hosts are talking about.
Whether you're just starting out or you really want to study some subtle abnormality, there's an interface level for you. Makes sense.
And once you're in there tweaking parameters, what do you actually see? How's the output displayed?
Good question. By default, it shows the standard 3-limb leads 1, 2, and 3. Pretty standard start.
Okay, the basics.
But the sources point out you can easily switch to a full 12-lead view.
Ah, adding the chest leads, so you get those different electrical perspectives on the heart.
Exactly, giving you a much more complete picture.
Yeah.
And that full view, it arranges itself pretty smartly too.
How so?
Well, it uses a conventional 4x3 grid on larger screens, but the source notes that for smaller screens, like maybe a phone or tablet, it cleverly adapts to a single-column scrollable layout.
Oh, that's...
Okay, so that's actually, yeah, we did have them in the grid, but that stopped working for whatever reasons. So we actually need to update the description. Let's actually do it straight away and run it locally as well. Because what I'm showing here is in production, so it's available for you to play with. Yeah, I'll pop it. The link should be in the comments or the description.
It's a nice touch. Good usability. Keeps it practical.
Yeah, it definitely shows some thought went into the interface design. And for the more technically curious listener, there's a little detail mentioned about how it keeps things running smoothly, especially when you're dragging sliders around and regenerating waveforms constantly.
Oh, you mean the web worker detail?
That's the
Yeah. The source explains that each time the waveform needs to be recalculated, which is happening, all the time as you adjust things, that heavy computation is pushed off to a separate process.
like a background task.
Exactly, running in what's called a web worker. It keeps the main display thread-free, so the interface, the sliders, everything stays responsive, even apparently on mobile devices.
Right, so it prevents that clunky, labby feeling you sometimes get with simulations.
It's that kind of behind-the-scenes engineering that makes it feel fluid.
Okay, so we've got this synthetic foundation, flexible interface level, smooth display. Now let's get to the fun part, maybe, where the real learning happens. Using the controls to actually manipulate the heart's rhythm and appearance.
Absolutely. This is where you start seeing cause and effect, which is, so valuable for learning. The most direct way to explore is probably the preset menu.
Right, which is kind of like a quick start guide to common rhythms, isn't it?
Pretty much. You can instantly jump to things like normal sinus rhythm or flip to bradycardia for a slow beat, tachycardia for a fast one.
And the sources mention specific examples too, like different AV blocks.
Ventricular tachycardia, atrial flutter, all those classic patterns you need to recognize.
Seeing those common patterns visually, right there, that seems fundamental to learning ECG interpretation.
Definitely. The presets give you that instant baseline for comparison.
But you're not just stuck with those presets, are you? You can fine-tune the speed yourself.
Oh, yeah, with the...
Okay, another thing is we actually have a JSON, now from memory. Yeah, in JSON file for the presets, we also have a description that's meant to be displayed somewhere on the screen. So we'll be doing that. So we'll have to eventually regenerate that podcast with the new version. Yes, so I have this JSON. let's actually go into this. We'll have, so it's the third version of our synthetic ECG generator. Third version. And so we have the HTML for it. Let's see what files we have there. Let's actually open Copilot. This is our CTO. We're feeling adventurous, so we'll be going straight to editing. Gonna be going straight to editing. But first we'll just ask to improve, to update the text at the bottom there. But first we need to share all the files. I'm pretty sure we need to be in the right folder as well. Right, so we are in the correct folder. We have all the files. We have the prompts. Okay. We might have changed a few things, so the prompts probably can go, because the prompts also have a copy of the code for whatever reason. So we don't want a reasoning model, we want something quicker. Do we? No. Let's keep it reasoning. Maybe 2.5 Pro is not that slow anyhow. So. Hey, can you quickly explain the prompts? Hey, can you explain this project? Would like to make a few modifications. So in the HTML, at the bottom of the page, we have text explanation and overview. Can we actually update that based on the rest of the files in this workspace, in this working set?
Okay, I'll update the descriptive text in your index.html file to better reflect the current capabilities of the ECG simulator based on the other files provided. Project explanation. This project is a web-based ECG, electrocardiogram, simulator. It allows users to generate synthetic ECG waveforms. It creates artificial ECG signals that mimic various heart rhythms and conditions. Select presets. Users can choose from a predefined list of common ECG patterns, both normal, e.g., normal sinus rhythm, sinus bradycardia, and abnormal, e.g., atrial fibrillation, ventricular tachycardia, STEMI. These presets are defined in presets.json. Customized parameters. Users can manually adjust various ECG parameters through a control panel. Basic controls BPM, beats per minute, noise toggle, and display mode, 3 or 12 leads. Asterisk intermediate controls asterisk window length.
Okay, this is super annoying. This is super annoying. A couple of things are annoying, actually. First, it keeps adding those footers. It didn't ask for a footer. Second, it removed some of the other descriptions. It's also removed some important bits on the page. Okay, now I'm getting confused. Wait a sec. Bear with me. Add files to part. No selection. That's right. Based on what the code does, what the web application does, can we modify the description? Don't modify anything else, and expand on it. If anything is still relevant, don't remove it.
Okay, I'll update the descriptive footer in your index.html file to accurately reflect the simulator's current features and controls, drawing information from the presets.json and the overall application structure. Index.html. Update the and.lt, footer and GT, content to provide a more detailed and accurate explanation of the ECG simulator's usage, features, and the available presets, referencing the description field in presets.json. Existing code /main ========================================================================================================================
Yeah, not sure why. I think it did okay. It's actually not showing the grid. What was the description of the grid? Does the code actually do the 4x3 grid? I think we had it in the previous version of the code. Is it still there somewhere? Okay, we actually have the previous description of this web application, so we might as well continue listening to it. We might pick up on something else.
BPM slider, beats per minute.
This is where you can really play, I guess. The source had that great analogy.
The tortoise
Yes,
like
the intention for the 12 lead display is to use a 4x3 grid on wider screens, 3 columns, and since there are 12 leads, this results in 4 rows. Your main.js script correctly changes the class of the div hashtag grid container to grid 12 when the 12 leads option is selected. This is handled in the build charts function. Grid.className equals leads.length equals 12, end quote, grid 12 end quote, grid 3 end quote.
Okay, something with the CSS rules that it wasn't actually showing, so it seemed to know what is it doing. Yeah, we ideally don't want a separate style section, but if it works, it works. Okay, that actually works fine, but just a minor thing. The grid, the 4x3 grid, is not fitting that canvas. You have another scrollers on the vertical and horizontal side. Can we get rid of that somehow? But first explain if you know what I'm talking about. So this is better. This is what we had originally as well. This is what we had originally as well. And one of the bots.
You're right, if the
got
12
rid
lead
of
grid,
it.
which is 3 columns and 4 rows of plots, is showing scroll bars, it means
Yeah, you can do it quietly. It's a minor thing. I'm sure you can make it better.
You can fine-tune the speed yourself.
Oh yeah, with the BPM slider, beats per minute.
This is where you can really play, I guess. The source had that great analogy.
The tortoise like crawl to a hummingbird pace.
Yeah, that one. It lets you instantly see how just changing the rate impacts the spacing between beats on the trace. Simple but effective.
Very. And then to make things a bit less, I don't know, textbook perfect, there's an add noise toggle.
Ah, yes. That sounds crucial for training your eye. Because real-world ECGs are almost never perfectly clean, are they?
Rarely. So this feature adds realistic artifacts. The sources list the types you can simulate. White noise.
Like random electronic interference.
Yeah. And 50 hertz noise, that typical power line interference you see in some regions. Plus motion noise, from the patient moving.
So you can actually practice seeing the real heart signal underneath all that garbage. That feels like vital training.
It really is. You also control the window length, deciding how many seconds of data are visible at once.
Useful for seeing single beats versus longer rhythm strips.
Mm-hmm. Then you get into the real nitty-gritty. The timing sliders for the PR, QRS, and QT intervals.
Okay, let's pause on those for a sec. For someone maybe just learning this, what do those actually represent on the ECG? Why tweak them?
Good point. So the PR interval basically measures the time it takes for the electrical signal to get from the atria through the AV node down to the ventricles.
Okay, so it tells you about that initial conduction delay.
Exactly. Then the QRS duration, that's the time it takes for the signal to spread through the ventricles, making them contract. Ventricular depolarization.
And a wide QRS often means a block somewhere in the ventricles.
Often, yes. Some kind of conduction problem there. And finally, the QT interval, that covers the entire period of ventricular activity, depolarization, and repolarization, getting ready for the next beat.
Right, and that one's linked to the risk of certain dangerous arrhythmias, I remember.
It is. So being able to manipulate these sliders lets you visually connect these specific physiological timings to the actual shape and duration you see on the trace.
Ah, okay. So changing the PR makes that first little bump, the P wave, and the start of the big spike, the QRS, move closer or further apart.
Correct.
Changing the QRS width makes that big spike fatter or skinnier.
Yep.
And changing QT impacts the whole beat duration, including that last bump, the T wave. Wow. Okay, seeing that happen live must be way more powerful than just reading definitions in a book.
Absolutely. It makes it stick. And you can even simulate changes that indicate, really serious issues using the ST offset slider.
The ST segment is often the big one people look at when they're thinking about heart attacks, right?
It is, yeah. Normally, the ST segment should be pretty flat, right on the baseline. This slider lets you elevate it or depress it.
And that's specifically useful for visualizing ischemia, lack of blood flow.
Exactly. Visualizing those ischemic changes you see in conditions like STEMI or NSTEMI.
So you could simulate the classic ST elevation you see in a STEMI, an ST elevation myocardial infarction, a major heart attack.
Correct.
Or the depression sometimes seen in NSTEMI or unstable angina. Be able to just dial that up and see what it looks like. That's powerful for recognition.
It really is. And just looping back quickly to specific block patterns, there are also Mobitz settings.
Right, for exploring those different types of second-degree AV block where beats get dropped.
That's the idea. Settings to let you mimic those characteristics, sometimes tricky patterns. And as we mentioned before, you can always toggle the display mode between 3 and 12 leads.
Getting those different electrical views of the heart, which is vital for figuring out where a problem might be originating.
Precisely. And finally, there's an export function.
Oh, what can you export?
You can grab the generated data as a CSV file. The sources node, it uses a 250 hertz sample rate.
Handy. If you wanted to pull it into another analysis program or maybe even, I don't know, build your own tools on top of it?
Could do. Or, more simply, you can just export the visual trace as a PNG image.
For presentations or notes, maybe?
Exactly. The source does mention that calibration pulses are omitted from exports just for clarity, which makes sense if you're trying to generate clean examples.
Wow. Okay, so you have this incredibly feature-rich environment. You can simulate basic rhythms, crank the speed way up or down, add real-world noise, drill down into the exact timing of the PQRST waves, even mimic the visual sign as major events like a STEMI. I mean, it sounds like the ultimate training tool.
It is for learning. And that brings us squarely to the most critical part of the sources, the part tucked away in the disclaimer and the additional overview section.
The catch.
The very big catch. Because while all that simulation power is fantastic for education, there is an absolutely vital caveat.
The big red warning sign we mentioned earlier. And it starts with that point you made right at the beginning. All these waveforms are generated synthetically.
This point absolutely cannot be overstated. The sources explain why they use synthetic data. It's clear for demonstrations. It's free from the countless variables and confounding factors you find in real medical data.
Confounding factors like, oh, I don't know, the actual human being attached to the monitor.
Exactly.
Their age, weight, electrolytes, other meds, whether they just climb stairs or are having a panic attack. Not to mention things like equipment glitches or iffy lead placement.
All of that. Synthetic data is clean, controlled. It lets you isolate the specific concept you want to demonstrate. And the sources are extremely explicit here because it's synthetic. It may not perfectly reflect all the nuances of real medical data.
And that leads directly to the non-negotiable rule, the big headline. This simulator should not be used for clinical decisions. Full stop.
Absolutely not. This isn't a tool for diagnosing a real patient sitting in front of you. The sources really double down on this by describing the presets, even things like normal sinus, bradycardia, or STEMI, or atrial fibrillation as just general approximations.
General approximations. Oof. Not the complex, messy, sometimes totally atypical way these conditions can actually show up in real life. You might see a STEMI pattern in the simulator.
The textbook STEMI.
Right. But a real heart attack can look significantly different depending on which artery is blocked, if the patient has old damage, their unique anatomy. The list just goes on and on.
Precisely. The sources explicitly state that each included disorder is a simplified model. You're learning the basic pattern, the idealized version, not the huge spectrum of how it presents clinically.
So, there's almost a dark humor here, isn't there? You could be happily dialing in this perfect-looking simulated VTASH, maybe adding a sprinkle of 50 hertz noise for authenticity.
Feeling quite pleased with your pattern recognition skills.
Yeah, feeling like you're mastering cardiology, while being completely detached from the terrifying reality of a human heart actually doing that. A situation where every second counts, and misreading a real trace based on an oversimplified simulation could be, well, catastrophic.
It's the ultimate sandbox, but you must remember it's not the battlefield.
Exactly. And that stark contrast is why that disclaimer is so crucial, isn't it? It's a powerful learning aid because it simplifies. But that very simplification makes it dangerous if you mistake it for reality.
The sources are practically yelling, do not rely on these synthetic traces for real clinical decisions. It's like they're saying, look, have fun practicing your pattern recognition, learn the basics, but for the love of God, when a real heart is involved, put this toy down and consult actual expertise and real data.
Which loops right back to the source's explicit advice. Always consult authoritative medical resources or qualified professionals when you're interpreting actual ECG data. There's just no simulation that replaces real-world experience and clinical judgment.
None whatsoever.
Okay.
Okay, we were banging on it too much. Now we have the description for each one of those that we would like to be displayed on the page somewhere. Yeah, just couple of quick things. First of all, the canvas. When we're showing the 3x4, the whole 12 leads, the whole canvas of the gate should not exceed about the 90% of the visible, or say 80% of the visible height, so we can see some of the text description below the page. Is that doable? And also, there is something wrong in the HTML. I think you added a bunch of comments or something into into the styling section.
Yes, both issues are fixable. Canvas height adjustment asterisk to ensure the canvas grid for 12 leads.
Okay, it seemed to understand what I'm talking about already. So I didn't need to complete my sentences. That's good to know. And yeah, it's updating the code. Now that podcast was generated by Notebook LM. Go check it out. But this is with the earlier description that we had currently deployed on the site. So we'll just finish listening to that.
So let's bring this back to you, the listener, especially if you're using tools like this to learn. We had this simulator, incredibly powerful, flexible, great for experimentation. And then we have this very blunt, absolutely necessary warning about its limits. How do you square that?
Well, the value for the learner is immense within its defined scope. The sources highlight this. It lets you see how changes in cardiac parameters alter ECG waveforms in a safe, controlled space.
Right, you can see cause and effect immediately.
Exactly. You can experiment with different presets or craft your own custom arrhythmias specifically to isolate and understand the key defining features of different conditions. That's invaluable.
It lets you build that fundamental visual pattern recognition library in your head without the intense pressure and, frankly, the noise and complexity of a real clinical setting.
Precisely. But the critical takeaway from that big disclaimer isn't just about this one simulator. It's a much broader lesson, isn't it?
Feels like it.
It's about the universal need to understand the source, the nature, and crucially, the limitations of any data or tool you use, especially in fields like medicine where accuracy is absolutely paramount.
Whether it's medical data, financial models, climate simulations, anything really. Knowing what the model doesn't capture is just as important as knowing what it does.
You've got it. This simulator, and perhaps more importantly, its accompanying disclaimer, actually teaches you that vital analytical skill. Critical appraisal of your tools.
Okay, so summing up our deep dive then.
Right.
We've got an ECG simulator that looks like a fantastic, dynamic, maybe even fun tool for learning the visual language of electrocardiography.
Oh.
It lets you really play with virtual heartbeats and see the results instantly.
And it's a huge but. It comes with that absolutely essential, potentially life or death reminder. It generates synthetic data, it offers simplified models, and it is strictly for educational purposes. It's a sandbox, not a real heart.
Which leaves us, and you, with maybe this final thought to chew on. In a world that's increasingly reliant on simulations, on AI, on simplified models to help us grasp complex realities, how do we cultivate the critical awareness we need? How do we get better at knowing when we're using a helpful illustrative aid versus when we might be mistaking a clean, simple model for the messy, nuanced, high-stakes reality it's trying to represent?
That's a really important question, one worth asking every time we look at a screen showing us a digital representation of something real.
Indeed it is. Well, thank you for joining us for this deep dive.
Our pleasure. Hopefully it provided some useful perspective on both the power and the critical limitations of simulation in learning.
Okay, so that was fun, but yeah, we are updating that at the moment. Yeah, get these things doing stuff like that. So we have Sonnet 3.7, Claude Sonnet looking at the code, at the HTML more specifically. Just polishing it up. Yeah, I really don't like things like that. Can you edit while it's generating? Yeah, we don't really need the footers, but no, you stuffed my page. Load 3.7 is getting a timeout. You're getting a timeout. Okay, there's a human in the loop, by the way, so if you have any meaningful questions, go for it. Go for it. Okay, just a couple of things in the current HTML page. In the current HTML page, there's a couple of issues. First of all, there's some linter error at the bottom, if we can fix that. Second, there's some comments that you added to the code. Can we get rid of those? And also, wait, what did we have for editing? We had 4.0 as well. Far out. Let's actually get rid of the styling there. Okay, we're having trouble. Having trouble. We are having trouble. Bow, bow. We are having trouble. Bow, bow. We are having trouble. We have the bots explaining everything we do. Yeah, let's bring Let's bring another bot, because we have lots of bots everywhere. Let's stream to Gemini Live. Okay, real quick, what do you see on the screen?
I see an ECG simulator is displaying ECG graphs with different parameters, like the preset rhythm and BPM.
Okay, wait a sec. Having an issue with the sound. I have like a crackling sound in Gemini, I don't know why. Okay, and when I click the 12 lead, what's happening and does it fit? How do we explain the developer? So we have a professional developer without any code. How do we ask them to actually improve the layout? What's happening at the moment?
When you click the 12 leads option, the display changes to show all 12 ECG leads at once, providing a more comprehensive view of the cardiac activity. To explain to developers how to improve the layout, you can suggest focusing on clarity and readability, ensuring the graphs are well organized and easy to interpret. You could also suggest optimizing the use of space, using consistent scaling, and adding clear labels for each lead to make it user-friendly.
Okay, that's not too bad, but yeah, we meant to, when in a 12 lead view, we meant to have a grid of, what is it, 3 by 4? No, 4 by 3. And that meant to fit, so it fits into the screen quite well. Can you rephrase it into a prompt?
Sure, you could tell the developers, please optimize the layout for the 12-lead ECG display, arranging the graphs in a 4x3 grid format to ensure clarity and optimal screen fitting.
Okay, that's not too bad, I think. Okay, let's do it again. So we have the whole. Oh, come on. Yep, ECG gen. We have a working set. Let's start a new chat. 4 by 3, 3 by 4, whatever. Yeah, well, meant to be 4 by 3 or 3 by 4. Not sure. Which model? Which model? Sonnet 4 would be an overkill. 3.7 meant to be good at coding. Let's give it the whole working set. Let's see what it. Please optimize the layout for the display, arranging the graphs, ensure clarity, optimal screen feeding. 3.7 or Gemini or 4.0. Let's do 3.7. Sonnet, not thinking, so it should be quicker. Okay, what is modifying? Yeah, the CSS. We're always having trouble with the CSS. We need to get rid of the CSS. I'll probably redo the whole lot. I think some of it is being changed in JavaScript as well. So that might be a problem. Okay, it seems to know what it's doing. Does it? Does it? Does it? does it knows what it's doing. And we're doing vibe coding, so not doing something silly as reading the code, do we? No. No, we don't. Because that would be very, very silly. Yeah, on the smaller screen we have the three. If anyone designs the ECG by chambers of heart, it would be a bit easier. Well, this is what the 12 leads are. They are looking at the whole thing. They are looking at the whole thing. You didn't finish the JavaScript. Didn't finish the JavaScript. Three percent for all. I think we need the big guns. Can we look at the code again? So I accepted the changes to the index HTML, but not to the JavaScript, because the previous robot was trying to remove a whole bunch of code, which we need there. So can you check check the code again? Check the code again. Check the code again. If anyone designs the ECG by chambers of heart, it would be a bit easier. If anyone designs well, maybe I don't know what you're talking about.
Okay, I've reviewed the main.js script you provided in the context of the index.html structure you've accepted. The main.js script appears to be the corrected version that addresses earlier issues with DOM element references and preset loading. It should generally work with the current index.html. Here,
can you do it quietly? I think we're modifying some of the styling for the page, but what? No. Wait, need to delete that, do we? I think we were modifying some of the styling to the page before, but some of the styling is controlled by the JavaScript. Is that correct? So we modified the HTML previously in terms of the styling, but I'm not sure if we need to make any adjustments to the main JS file. It actually works fine at the moment. It actually works fine. But this notebook LM, the interface is a bit shocking.
you are correct. The main.js file interacts with the page's styling, primarily.
Okay, I can do that quietly. Need more robots, more robots. More robots is a solution for everything, isn't it? Okay, so we have this page. We have this page. Hey, go check out the site. Everything we do is available on the website. So we have this currently in Pro. Okay, so we have this thing. We can describe it quickly. And then we have this prompt by someone. Let's see. Well, because Notebook LM is only answering questions about the sources we added. We can discover more. Wait, how does discovery works? How does discovery works? Not sure it does. Okay, so it's saying no specific adjustments. Will give us a whole bunch of stuff. Well, this might be actually copyrighted, so it's good it found those sources, a bunch of YouTube videos and stuff. Actually, Gemini generated a response. What we can do is take that response, put it in Notebook LM. Okay, so could we have a refresh button? Still going for mainly the first. It's going for mainly. Okay, that's weird. That's weird. That's weird. What if when we customize, let's make it talk about that default length, that's fine. Yeah, we have a meaningful comment in the chat, so we might as well answer it properly or address it properly. So, sorry, not answer. We don't have an answer. There's no answers, only questions. Okay, currently. Okay, we have this on the servers, not in production yet. Just trying to see how it will load on a smaller screen. Should even load on the phone, okay. Maybe not. Maybe, maybe. Yes, that's actually quite nice. I like it very much. All right. Hey, there's another thing. So waiting for the professional podcasters to do their job. But another thing is, so we're having a lot of luck with Gemini 2.5 coding wise, well, and everything wise. So it's both our CEO and CTO. Thank you very much. By the way, we have other ECG tools as well, which you can check out on the site if interested. Guess we have this running in production, and the preset hey, okay, quick something if we can address in the preset JSON file. We also have a description for the current chosen ECG waveform type or abnormality, whatever. So what would you do with it? What would you do with the description? Can give you a clue.
Okay, I understand. The description field in your presets.json for each ECG type is valuable information. We can display this description dynamically on the page whenever a user selects a preset. Here's how we can do it.
Okay, that's pretty amazing. Yes, you do understand. You do understand. And we had a meaningful question in the chat. Should we do interactive mode? Well, let's download it first just before we lose it. Can do interactive.
Welcome back to the Deep Dive. We're jumping straight into a fantastic question one of you sent in, along with some really thought-provoking sources.
Oh, good.
It touches on something fascinating. How do we simplify complex things like learning the electrocardiogram, the ECG?
Right.
Your question is specific. Would designing an ECG simulator specifically focused on the heart's individual chambers, the atria, and the ventricles actually make that learning process easier?
It's a brilliant question. Really is, because it gets right to the heart, if you'll excuse the pun.
Yeah.
Of connecting the physical structure, the anatomy of the heart, to
Have to
those
love the puns.
electrical squiggles we see on an ECG trace. And the sources you've provided, they really dig into this exact concept. They look at both the potential upsides of a chamber-centric approach and, importantly, the significant hurdles you'd likely run into.
Okay, let's unpack this idea then. Our main source exploring this is something we're calling the chamber-centric ECG simulation paper. And it makes a pretty bold assertion right off the bat, suggesting that, well, honing in on individual chambers could really simplify things, especially, it seems, for beginners.
That's where it starts, yes. The core argument there is built around what they call potential advantages for easier understanding. They propose that this focus could make that initial link between the heart's action and the ECG waveform much more, well, intuitive.
And what are those key advantages they highlight? How would it make it more intuitive?
Okay, so the first big one is creating a more direct correlation with physiology. Think about when you're first learning the ECG, you see a P wave, then a QRS complex, then a T wave.
Right, just lines on paper.
Exactly. And you wonder, what does that mean is actually happening inside the heart? The paper suggests that a chamber-focused simulator could visually and maybe interactively link, say, the atria depolarizing, the electrical activation spreading through the upper chambers directly to the P wave forming on the screen,
Oh, I see.
or showing the big electrical event of the ventricles depolarizing as the QRS complex appears. They describe this kind of direct visual and interactive connection as potentially very powerful for helping learners grasp the anatomical source of those electrical signals.
So instead of just seeing a line appear abstractly, you'd maybe see the part of the heart generating it sort of light up or animate.
Exactly that. It grounds the abstract waveform in the concrete anatomy. much more tangible.
Makes sense.
The second advantage they point out is around understanding chamber-specific pathologies. So when someone has a problem, say, mainly in the atria, like atrial enlargement where they're bigger than normal, or in the ventricles, like ventricular hypertrophy, meaning the muscle wall is thickened,
Okay.
this kind of simulator could potentially make that connection clear. The paper suggests a user could maybe tweak parameters for a single chamber, like just hypothetically increasing the muscle mass of a ventricle in the simulator,
Right.
and then instantly see how that specific change manifests on the resulting ECG tracing. It highlights how an abnormality localized to one part of the heart affects the overall electrical picture we see.
That makes a lot of sense. You could isolate the issue, sort of play with it, see its specific impact, rather than just being presented with a finished abnormal ECG and trying to work backward.
Precisely. And what about basic rhythms? They cover that too.
Oh, good. Like AFib or VTAC.
Yeah, exactly. For foundational rhythms that originate in a specific chamber, things like atrial fibrillation, which starts chaotically in the atria, or ventricular tachycardia, which is that fast, abnormal rhythm originating down in the ventricles, understanding their source, where they come from, would be far more straightforward if the simulator visually and interactively emphasized the contribution of that particular chamber. It helps reinforce the idea of where the electrical problem is starting.
So the vision seems to be something like a visual representation of the heart on screen, maybe those chambers changing color, animating as electricity flows through them,
Uh-huh.
and users manipulating settings specifically tied to those chambers, like adjusting an atrial rate slider or a left ventricular muscle thickness input. It does sound promising for building that initial intuition, that first step.
That's definitely the potential they see, yes. It aims to simplify that crucial first step of linking the electrical signals back to the heart's physical components.
Okay, so the potential benefits for easier basic understanding seem clear. But, as anyone who's tried to learn ECGs knows, easy is rarely the whole story when it comes to the heart's electricity. And the chamber-centric source doesn't shy away from the difficulties, does it?
Not at all. It makes a very important transition to discuss the important considerations and potential complexities. It highlights that while focusing on chambers is a compelling idea for simplifying things initially,
Yeah.
the reality of the heart's electrical system is far more integrated and complex than just like the sum of its four chambers acting totally independently.
Okay. What are the main hurdles or complexities they point out?
Well, the first major one is the risk of oversimplification. The paper's very clear here. The ECG doesn't record the electrical activity of each chamber in isolation. It can't.
Right.
It records the summed electrical activity of the entire heart, and importantly, it views that summed activity from different angles, those are the leads we place on the body.
Got it.
It's explicitly not a direct feed from individual chambers. So if a simulator only focuses on chambers, it might inadvertently teach a learner an incorrect mental model, one where chambers are kind of isolated electrical units rather than parts of a continuous interconnected electrical field. You could miss how the electrical forces from one chamber interact with, or maybe even cancel out others, or how they propagate through the surrounding tissue.
Right. It's like trying to understand a symphony by only listening to the violin section. You're missing the whole orchestra, how it all works together.
That's a good way to put it, yeah. And crucial to that whole orchestra is the role of the conduction system. This is the heart's own specialized electrical wiring network. The SI node, the AV node, his bundle, the Purkinje fibers.
The pathways.
Exactly, the pathways. These structures aren't the heart muscle chambers themselves, but they're absolutely crucial for coordinating heart activity by timing and directing the electrical impulses correctly. The source emphasizes that any chamber-focused design must still accurately represent how impulses travel between chambers and through this system, because many common ECG abnormalities, like heart blocks,
Uh-huh.
aren't actually problems with the chamber muscle itself, but with issues within these specific electrical pathways. A simulator ignoring this system just wouldn't accurately represent how the heart works electrically. It would miss a huge piece of the puzzle.
So you need to simulate not just the batteries, let's say the chambers generating the electricity, but also the wires connecting them and telling them exactly when to fire.
Precisely. It's the timing and coordination that these pathways provide that is absolutely essential for normal heart function and, consequently, for a normal-looking ECG.
Okay. What else?
Another major complexity is the vectorial nature of ECG. The paper reminds us that the ECG actually records the direction and magnitude of electrical vectors.
Vectors, right? Like in physics.
Sort of, yeah. What it means is the net electrical activity of the heart at any given moment can be of as an arrow, a vector pointing in a specific direction and having a certain strength or magnitude.
Okay.
And the different ECG leads we use, they're essentially like cameras positioned around the heart, each one seeing how much of that overall electrical arrow is pointing towards it or away from it. Understanding concepts like the heart's electrical axis, which is the average direction of electrical spread during ventricular contraction, requires thinking in terms of these overall electrical forces and their direction, not just what a single chamber is doing in isolation.
Okay, that definitely adds another layer of complexity. It's not just about when a chamber fires, but the direction the electrical wave travels through the muscle tissue and how that overall picture looks from all those different viewpoints on the body.
Exactly right. And finally, the paper points to the sheer modeling complexity involved. Creating a simulator where you can adjust parameters for individual chambers, okay, fine, but then also accurately model how their electrical activity sums up and incorporate the conduction system's precise timing and pathways, and model how the electrical wave actually propagates through the heart muscle tissue, and then simulate how all of that looks from 12 different angles on a standard ECG. Well, making all that work together to produce a physiologically accurate, clinically realistic tracing is described as, frankly, very complex.
Wow. Yeah, so we see this really interesting tension laid bare here. There's the potential for simplifying the initial learning by focusing on the basic anatomy,
Uh-huh.
versus the inherent, maybe irreducible complexity of the heart's electrical system as a whole, integrated dynamic entity. The source seems to highlight that making it simple enough for beginners without losing the fundamental truth of how the ECG is actually generated is a really significant challenge.
That's the core takeaway from that first source, I think. It maps out a potentially helpful approach, but it's very grounded in the reality of the physiological complexity. You can't just wish that complexity away.
Okay, let's pivot then to the second source. You shared this description of an existing ECG simulator. Now, this one doesn't explicitly market itself as chamber-centric, but looking at its features, it seems it does allow you to manipulate things that are, well, related to chamber activity and conduction, right?
It does, yeah. The description lists a range of controls. There's a preset menu for common rhythms, which is useful, a BPN slider for heart rate, obviously, options to add noise, adjust window length for viewing.
Standard stuff.
Yeah, standard stuff. But importantly, it also lists parameters for timing, PR, QRS, QT, an ST offset adjustment, noise source sliders, and specific Mobit settings. And it can display the standard 3 or 12 leads.
Right, so you see those timing, PR, QRS, QT, and Mobit settings, and immediately think of our discussion about chambers and the conduction system. Those seem relevant here?
Absolutely. These parameters, while they aren't labeled atrial traction time or ventricular depolarization speed or anything like that,
No.
they directly correspond to electrical events that are linked to specific parts of the heart or the conduction system. The PR interval, for example, represents the time it takes for the electrical signal to travel from the SA node way up in the atria through the AV node and down to the ventricles. So manipulating the PR setting in a simulator directly affects the simulated conduction time between the atria and ventricles.
And QRS is related to the ventricles, spreading through the ventricles.
Exactly. The QRS duration reflects the time it takes for the electrical impulse to spread through the big ventricular muscles, and the QT interval covers the entire process of ventricular depolarization and repolarization, essentially, the complete electrical cycle of the main popping chambers. So, by letting users adjust these specific timing intervals, simulators like this are implicitly allowing you to modify parameters directly reflecting atrial activity, AV conduction, and ventricular activity.
And the Mobit settings, those must be about those conduction pathway problems we mentioned earlier, heart blocks.
Precisely. Mobits refers to specific types of AV heart block problems where the signal isn't conducting properly from the atria down to the ventricles, usually via the AV node and the His-Perkins system. So that setting explicitly lets you simulate abnormalities within the conduction system itself.
Okay. So this existing simulator, by allowing you to manipulate timing intervals and specific conduction issues, is actually already touching upon the very areas that the chamber-centric source says are important for understanding the ECG.
It really is. And interestingly, the chamber-centric paper kind of connects these ideas. It suggests that a more explicit chamber-centric interface, meaning maybe adding those visual heart representations we talked about and more chamber-specific parameter labels, it suggests that could be a beneficial layer on top of such functionalities that are already present in simulators like this one.
So not necessarily replacing them.
Right. It's not necessarily advocating for tossing out interval-based controls, but potentially adding an anatomical or chamber-focused view maybe as an option to make that link between the intervals and the underlying anatomy clearer, particularly for new learners. An enhancement, perhaps.
Okay, this deep dive has really clarified the landscape around this whole idea. It seems like from these sources, we've pulled a few key insights. First, a simulator explicitly designed with a chamber focus does seem to have clear potential to simplify the basics of ECGs for people just starting out.
Uh-huh.
It could make that crucial initial connection between the heart's anatomy and the PQR's TA form more intuitive, maybe by showing how specific chambers contribute to specific parts of the tracing.
Right. That initial grounding seems like the main appeal. But the second major insight, and it's a big one, is that while that anatomical link is powerful for fundamentals, you absolutely cannot escape the underlying complexity of the whole system.
Yeah.
A comprehensive understanding still demands grappling with the conduction system's critical role, the vectorial nature of the electrical field we discussed, and the fundamental fact that the ECG is a summed signal from the entire heart, not just easily separable outputs from individual chambers. The challenge, as the source implies, is simplifying enough to teach effectively without oversimplifying to the point of being misleading about how the ECG is fundamentally generated. It's a fine line.
And for you, the listener, thinking about this potential approach and its inherent challenges really highlights a fundamental truth about learning the ECG, doesn't it? It's not just about memorizing patterns on paper. It's really about building a mental model of the underlying electrical physiology of the entire integrated heart, and then learning to read that complex activity from different viewpoints, which is what the leads give us.
Absolutely. And exploring simulators that exist today, even if they don't have explicit chamber labels, can still be incredibly valuable. By manipulating parameters like the PR interval, the QRS duration, the QT interval, you're directly seeing how changes in underlying cardiac events tied to conduction and chamber activation affect the final tracing. It reinforces the idea that the ECG is a dynamic representation of physiology, not just static shapes.
We've taken a really interesting deep dive today into this idea of a chamber-centric ECG simulator, looking at the potential benefits, the significant complexities, and how existing tools already touch on some of these key areas.
And drawing on the sources one last time, which really emphasize that the ECG is a recording of the summed electrical activity of the entire heart, viewed from different leads, and they stress the absolutely crucial role of the conduction system, which is separate from the chamber muscle itself. Well, this inherent complexity leads to a fascinating question for you to maybe ponder.
Okay.
What does trying to simplify such a dynamic, interconnected biological signal for learning purposes tell us about the necessary perspective we must ultimately adopt to truly understand it? Is perfect simplicity ever really achievable here? Or is acknowledging and embracing the complexity inherent in the signal itself the only way forward?
A great thought to leave everyone with. Thank you so much for sharing your question and the sources. They really sparked a fantastic conversation today. Keep exploring these ideas, and we'll see you on the next deep dive.
Okay, can you paraphrase the original question? We want to edit. Can you? Can you? Can you? Can you? What the? Can you paraphrase the original question? We want to edit as a Q&A on the website, but the answer will be in audio form. But yeah, we just need to paraphrase the question first. And the other thing, yeah, I want to change those. With the timing and the noise controllers, how would you improve the user interface? Would you turn them into sliders by any chance? What do you think?
Yes, converting the timing and noise number inputs into sliders is a good idea. It would make the interface more consistent with the existing BPM and window length controls, and sliders can be more intuitive for adjusting values within a defined range. Here's how you can implement these changes.
Okay, the sliders will be better, but let's see. And I'm wondering if we need to adjust anything. So it will be the intermediate controls. Is this one? Is this one actually working? All right. Yeah, PR. Yeah, it is working. What's it? Ah, seem to be working as is. So it seemed to be working as is without modifying the JavaScript. Can you explain why? Also, can you explain how to change the styling so that the label of the slider appears on its side, on the left, and the label and the slider are in one line? Wouldn't let me finish. Wouldn't let me finish.
It's good that the basic functionality seemed to work. Here's an explanation and how to adjust the styling. Why it seemed to work without JavaScript changes. Existing generic listener * your main.js likely already had a loop that attached an input event listener to all relevant control elements.
Yeah, it's not giving me specific information about the code. So what if I just apply this? Yeah, I'm not sure which model is using for modifying the code now. And it's stuffed it up. Yep, wasn't able to do it. Discard. All you meant to do is copy. I think. There's only these two file tests. Field set. Right. This is a bit better. This is a bit better. Is it? Is it? Is it? Yes, it is. Okay. The add noise thing needs that. Let's go address that as well. There's endless number of things. Now the add noise controller, the taking the thing. First of all, why is it it needs to be in the noise section, isn't it? And second of all, can we potentially not have it? Just have the sliders. The sliders seem to work okay, so we don't need the add noise yes or no tick box controller, do we? Do we? Do we? Do we? Do we? Do we? I think with the motion keeps adding the motion randomly in different places, which is fine. Yeah, you can see it here and there. Is it over there as well? What? 2.5 Pro just timed out on me, but that's within Visual Studio Code. That's interesting. Please wait 10 hours, 10 hours, 10 hours, 10 and a half hours. What? It's crazy. Crazy. They never tell you what the rate limits are. Field test. No, I'll have to get rid of stuff in the JavaScript as well, won't we? Won't we? Okay, what do I need to remove from the JavaScript?
To remove the Add Noise checkbox functionality from the JavaScript, you need to remove references to noise toggle in the code. 2. Ensure the noise-related sliders, N-white, N-mains, N-motion, still work independently. 3. Update the
They do work independently. They do work independently. What? I don't know how difficult this task is. That's the other problem. So we use the reasoning model. Use the reasoning model to remove noise toggle. And we ensure the relevant noise sliders. White mains motion still work independently. We're updating the update function. Updating the update function. Excuse the pun. To exclude the noise toggle logic. Noise toggle logic. Because we don't need that tick box. The noise could be minimal to begin with by default. You should be able to adjust it yourself. Claude 3.7 thinking takes forever. Date. Did you just redo the whole code? I think so. Wait a sec. Mm. Okay, we stuffed it up, stuffed something up. Okay, something doesn't work correctly. We removed the tick box, the controller for the noise on and off. So now it should be on by default. I mean, we don't have it anymore, but now the noise controller, the millivolts mains in motion should be able to control the noise. It doesn't at the moment. Can we fix that? Can we check the code? Don't make any changes. That's the solution.
To fix the issue, we need to ensure that the noise sliders, N white, N mains, N motion, are properly integrated into the update function and that the noise parameters are always applied regardless of the removed checkbox. The issue might be that the logic previously relied on the noise toggle checkbox to enable or disable noise, and now the sliders are not being processed correctly. Here's the updated update function to ensure noise is always applied based on the slider values. Function update. If presets, preset cell dot value, return, / wait for fetch. Const p equals presets, preset cell dot value. Const perms equals PR plus.
Having much luck. Let's do all 4 mini the OpenAI models, because we can't go back to Gemini because it's all in separate files. Well, yeah, at least. Well, probably can, but will be too complicated to move to port the code. Okay, the noise controllers do not work. The noise controllers do not work at the moment. They don't actually add the noise, which used to work well before, when we had the controller for noise on and off. But now we remove the controller for the noise on and off. But now the sliders meant to be just adding noise by themselves, but they don't do it. Can you check the code? Wait a sec. The problem is that it doesn't have Hey, can you make sure you are looking at the entire code base as well? So this is O4 mini. Let's see what it can do.
Plan. In. Worker.js. Replace the old if, p.noise, check with a guard on your new slider props. p.
Okay, they added these weird things. All right. What? Okay, we need to modify. We need to modify this thing. Apply changes. Not sure which model it's using to do it. Like modifying the whole code base. No, it did. Okay, that looks legit. Okay, it's working. What do you know? What do you know? I don't know anything. What do you know? What means? What's the default? Yeah, the default is that 3 leads. If the screen is smaller, it will be. Sorry, the default, depending on your screen size. Okay, that's good. We're making a lot of progress. A lot of progress. Yeah, all 4 mini was able to make it work. Yeah, working real well. Working really well. So I want to add that. So we had a question, had a meaningful question. Well, the original question was if anyone designs the ECG by chambers of heart, it will be easier. Well, yeah, it will be easier. Yeah. Now that I'm reading it again and again, the comment might be a bit. Okay, so we revised the comment. If the ECG simulator is designed to show how each of the heart's chambers contribute to the overall waveform, would this make ECG easier to learn? Well, yeah, you bet. You bet. And then we had a whole discussion about this, which we will place as a question. Yeah, we don't need 3.7 solid for it. We can just do GPT-4o. Okay, we'll have a Q&A section. Can we place this as a separate section, text section? Place the following question. Let's see what it does. Should have the question over there. Okay, I'm actually trying to turn it into this audio one. Let's just keep the original. And let's call it chambers. Get rid of that. Okay, can we add this audio file as an answer to this question? And can you make the whole section clearer? Redo the whole section. And this is the file. Okay, interactive learning question. Consider this. If an ECG simulator was designed to visually demonstrate how each heart, blah, 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 which make ECG easier. Yeah, that's pretty good. Can we have these two sections in a single line somehow?
Made changes.
Made changes. Yeah, that's right. And can the audio interface take the rest of the screen?
Made changes.
But still have the text in the same line.
Made changes.
That's right. What happens? On a smaller screen, it still kind of works, so that's very nice. Hey, can we have a different background for this section?
Made changes.
Made what? Right, just happened. Yeah, right, this is better. Don't like the border radius thing.
Welcome back to the deep dive.
Could maybe tweak parameters for a single.
I guess that works on the page itself. Yeah, there's always problems with like the styling of this thing. Okay, can we actually simplify the styling of this page and also the styling in the JavaScript? Some of the styling is controlled within the JavaScript, as you know, but we would like to simplify it and essentially load by default all the time. In any case, load depth of 3 leads only, and then just have the option for the 12 leads if someone wants it, and then the intermediate and expert menus, control menus. It didn't let me finish talking. It's pretty annoying. And we'll have an overview for the whole page as well in audio. I think might be actually ready to do that. Do we? Do we? Yeah, currently it does all this.
Collecting workspace information. You can remove all of the inline AnJS styling and push it into a single CSS file. Then let your grid layouts handle sizing automatically. Here's how you might do it. Add a new
Yeah, that's probably not a bad idea. Not a bad idea. We'll stuff things up, won't we? Okay, can we do one thing at a time? Can you generate the complete CSS file? First thing first.
Here's the new styles.css. To centralize all styling, drop all inline styles and link this file in your HTML/*1. Reset */ box sizing.
Yeah, you can do it quietly, obviously. Yeah, I'm not sure why I'm deleting sources. We can just start a new chat. We can do Hey, can you tell me how awful this tool is? Let's try that. I'm not sure how. The instructions. It's to default is fine. Okay, it will generate it based on the text on the page. Yeah, trying to sort out the styling for this page. Currently it's too complicated. Yes, we can get okay, can you keep guiding me as to how do I modify the HTML? Wait, we having a problem? A problem. It's the wrong file. Okay, this should be better. Okay, this is annoying.
All right, welcome to the deep dive. Today, we're taking a look at a specific tool. We got some documentation sent over.
That's right. We're diving into the Bionic Chaos ECG simulator. And importantly, we're sticking strictly to its official guide.
Yeah, just the guide. Nothing else. Our mission, really, is to unpack what this guide tells us the simulator is, how it works, what it's supposed to be for.
Exactly. Solely based on the Bionic Chaos ECG simulator guide. We're kind of reverse engineering our understanding from the manual alone.
So think of it like we're reading the instructions together. We'll go through how the guide describes it, the features it lists, and crucially, its purpose and limitations.
Yeah, maybe you can sort of picture using it as we talk through what the guide says you can do with it.
Okay, so let's start right there. What does the guide actually say this thing is? What's the basic description?
Well, the guide calls it an interactive tool. And its main job, as they describe it, is letting users explore different heart rhythms.
Exploring rhythms and something about parameters.
Yes, and seeing how specific electrophysiological parameters actually change the ECG waveforms you see.
Interactive seems key. Like you're meant to play around with it.
Seems so. And the guide is very upfront about why it exists.
Which is?
Strictly for educational and illustrative purposes. Only that. It makes that point very clearly right from the start in the documentation.
Educational and illustrative. Okay, so definitely not for, real patients.
Absolutely not. It's framed as a learning aid.
Got it. So how does the guide say you actually interact with it? It mentions a control panel.
Yeah, the documentation talks about a control panel over on the left side of the screen.
And it's organized in a specific way.
It is. The guide highlights this structure. It's split into 3 sections.
Ah, right. Basic, intermediate, and expert. I saw that. That structure itself kind of tells a story, doesn't it?
It does, yeah. It suggests, different levels of control. Maybe you start simple, then get more advanced.
Like layers of detail you can access?
Precisely. You could start by just picking something pre-made, or you could dive deep and tweak the parameters that actually build those rhythms.
Okay, let's walk through that. What does the guide say is in the basic controls? Where do you start?
The guide suggests starting by picking a preset rhythm. That seems to be the main entry point in the basics section.
Like the quickest way to see something common.
Exactly. Load up a standard example of a cardiac pattern.
And the guide lists quite a selection of these presets, right? I remember seeing things like normal sinus rhythm, AFib.
Oh yeah, the list in the guide is pretty extensive. Normal sinus, atrial fibrillation, VTAC, various blocks, first degree, Mobitz first, Mobitz 2, complete block.
Wow, okay. What else?
It also mentions, according to the document, acute steme, both anterior and inferior are listed, and stemness depression, junctional rhythm, multifocal atrial tachycardia.
So quite a library of examples built in based on the guide. It seems geared towards covering a lot of key ECG findings you'd want to learn.
It definitely looks that way from the list. And the guide notes that each preset actually comes with a little description.
Oh, that's useful. Like what?
Like for normal sinus rhythm, it might say, rate 60-100, regular, P wave before every QRS, that kind of thing. Basic definitions right there.
So it connects the visual pattern to the clinical description right in the tool, as the guide describes it. Helps with the learning.
Exactly. Reinforces the link between the trace and its characteristics.
Okay, so besides picking a preset, what else is under basic controls according to the guide?
Let's see. The guide says you can change the overall heart rate, the beats per minute. Simple enough.
Okay.
There's also a toggle switch for noise, just on or off.
Noise, like interference.
Presumably, yeah. Some kind of artifact or baseline fuzz. And you could choose how many leads to display.
How many?
The basic options are 3 leads or 12 leads.
Right. And the guide also mentions the export function here.
It does. It points out that export gets enabled after you generate the first waveform. We can talk more about the formats later, but it mentions CSV and PNG right there in the basic section description.
Makes sense. You'd want to save what you've simulated. Okay, moving up. What does the guide say about the intermediate controls?
This seems to be where you start fine-tuning things. The guide says you can adjust specific ECG timing intervals, like the PR interval, the QRS duration, and the QT interval. And it specifies these are in milliseconds.
Ah, so getting into the actual measurement.
Exactly. And you can also tweak the ST offset, which the guide says is measured in millivolts.
Okay, so this is where you'd start to see what happens if I make the QRS wider, or what if the ST segment is elevated?
Precisely. The guide suggests this lets you explore how those fundamental timings and voltages directly impact the waveform shape. You're not just seeing a fixed preset, you're manipulating the components.
You're kind of building it yourself, in a way.
Sort of, yeah. Seeing the cause and effect. The guide also lists different kinds of noise you can adjust in this intermediate section. Not just on-off, but levels.
Oh. What types of noise does the guide mention?
It names 3. White noise, 50 hertz noise, which it specifically labels mains noise.
Like electrical interference from plugs and things?
That's the implication in the guide, yeah. And also motion noise, like artifact from movement.
Interesting. So the guide shows you can simulate those common artifacts you fight with on real ECGs. Adds a bit of realism, maybe?
Or at least helps you learn to recognize what noise looks like, even in this simulated space. It adds that layer of complexity the documentation describes.
Right. Okay, let's go to the top tier then, as described by the guide. Expert controls. What's the deal there?
Well, like the name suggests, the guide positions this section for, more advanced users or situations. It's where you customize very specific parameters for complex rhythms.
Can you give the example the guide uses?
Yeah, the guide specifically mentions simulating second-degree AV block, Mobitz first, that Venkaback pattern.
Okay, and what can you control for that?
For that specific rhythm, the guide lists expert parameters like Mobitz cycle length in beats and Mobitz PR step in milliseconds.
Ah, so the PR step would be how much the PR interval increases with each beat before the dropped beat.
That seems to be exactly what the guide implies. You can directly model that characteristic progressive lengthening.
That's quite specific. So it sounds like these expert controls, according to the guide, are really tailored to the underlying mechanics of certain arrhythmias.
That's what the example suggests. They let you dig into the sort of electrophysiological details that create those specific complex patterns as described in the documentation.
Okay, fascinating. So we've covered how the guide says you make the waveforms. What about seeing them? It mentioned 3 or 12 leads earlier.
Right. The guide goes into a bit more detail on the display modes. It says the default is the 3-lead display.
Which leads are those, typically?
Standard limb leads we on 9, 2, and 3. And the guide says they're usually shown vertically stacked.
Okay. And the alternative is the full 12 lead.
Correct. The guide states this mode shows, all 12 standard leads. Limb leads 1, 2, 3, AVR, AVL, AVF, plus the chest leads V1 through V6.
And how does the guide say they're laid out?
Typically it says in a 4x3 grid on wider screens. That's pretty standard for viewing 12 leads.
But it adapts. The guide mentioned something about smaller screens.
It does, yeah. A nice detail in the guide is that it points out on smaller screens, like phones, the 12 leads become a single scrollable column.
Sensible. So the guide indicates the display is designed to be usable regardless of your screen size.
Seems like a practical consideration mentioned in the manual.
Okay, let's peek under the hood a bit based on what the guide tells us. How does it say the simulator actually generates these waveforms? Any technical bits?
It does give one key technical detail. The guide mentions that the waveform generation, all the math, happens in a background web worker.
A web worker. Why does the guide point that out? What's the significance?
The documentation explicitly says this keeps the user interface responsive.
Ah, so the controls don't freeze up while it's crunching the numbers for the ECG.
Exactly. The guide presents this as a technical choice for a better user experience.
Mm.
The calculations run separately, so you can still click and slide things smoothly, according to the manual.
Okay, that makes sense. Anything else technical the guide mentions? Like sampling rate?
Yes, it mentions a fixed sampling rate for the output, 250 hertz.
250 samples per second. Got it. And what about those little square calibration pulses you often see on ECG printouts? Does the guide say they're included?
No, the guide is explicit here. It says calibration pulses are omitted from the display.
Why?
The reason given in the documentation is for clarity and simplicity, just focusing on the waveform itself.
Another simplification for that educational goal, it seems. Okay, speaking of output, the guide mentioned export earlier. Can we circle back to that? How does the guide describe getting the simulated data out?
Sure, the documentation details two formats. First is CSV, comma, separated values.
A text file, basically. What data is in it?
The guide specifies it contains time data in seconds and the corresponding voltage values in millivolts.
For which leads?
And here's a key point the guide makes. It includes the data for all 12 leads.
Even if you were only looking at 3 leads on the screen.
Yes, regardless of the display mode at the time, the guide says the CSV gives you the full 12-lead dataset sampled at that 250 hertz rate.
Wow, okay. So that CSV output sounds pretty comprehensive. Based on the guide, you get the raw numbers for everything. Could be useful for, I don't know, further analysis or something.
It provides the underlying numerical data of the simulation. The second format the guide describes is PNG.
An image file.
Right. The guide says the PNG export gives you a snapshot, an image of whatever leads were currently visible on your screen when you hit export.
So what you see is what you get visually.
Exactly. The guide suggests this is good for, quickly sharing a picture or putting it in a presentation.
Okay, so CSV for the full data, PNG for the visual snapshot. Makes sense. Now, there's a really important section in the guide that we need to cover properly, the disclaimer.
Yes. The guide is very direct about this, no ambiguity at all.
Let's make sure we really nail what the guide is saying here. What's the absolute core message?
The guide states, point blank, that all the waveforms you see in the simulator are synthetic. They're made using mathematical models.
Synthetic,
Yeah.
not real. And it hammers home the purpose again.
It does. Reiterates they are only for educational and illustrative purposes, nothing else.
And the big do not use for?
The documentation is emphatic. Do not use these synthetic waveforms for any clinical decision-making, no diagnosis, no treatment planning. The guide says it's completely inappropriate for actual clinical use.
Why does the guide draw such a hard line? What reason does it give?
It explains that real-world ECGs are just way more complex. They have much more variability than the simulator could possibly show.
Due to?
The guide mentions things like individual patient differences, how the recording was done, just the inherent biological complexity. The simulator, it says, has to simplify things to be clear for learning. It provides idealized models.
So the guide is basically saying, look, this helps you learn the concepts, but don't mistake these clean models for the messy reality of patient ECGs.
That's precisely the message from the guide's disclaimer, and it reinforces it by telling users to always go to proper medical resources and qualified professionals for interpreting actual clinical data. The guide itself defines the tool's boundaries.
That level of clarity in the documentation is really significant, managing expectations right there in the guide.
It's a critical boundary set by the source material itself.
Okay, one more thing from the guide before we wrap up. It includes something called an interactive learning question.
Ah, yes. It poses a question directly to the reader, the user of the guide.
What's the question?
It basically asks you to think about whether it would be better for learning if a simulator could show how each individual heart chamber, the atria, the ventricles, contributes its part to the final ECG waveform you see.
Huh. That's interesting. A pedagogical question right in the manual.
Yeah, it prompts the user to think about learning design itself. Could simulation be done differently, perhaps more effectively, by breaking down the signal sources visually?
Makes you reflect on how you learn best, using the tool described in the guide as a starting point.
Exactly. It shifts the focus slightly from just using the tool to thinking about how such tools teach.
Okay, I think we've thoroughly mined the Bionic Chaos ECG Simulator Guide for what it tells us. Let's try and summarize the main takeaways from this document.
All right. So, based purely on the guide, the Bionic Chaos ECG simulator presents itself as an interactive educational tool, strictly educational.
Right.
It's got that structured control panel, basic, intermediate, expert, a big library of preset rhythms, each with a description, options to display through your 12 leads.
And ways to get stuff out.
Yeah, export options. CSV for the full 12-lead data at 250 Hz, and PNG for a visual snapshot of what's on screen.
And the absolute must-remember point the guide makes over and over.
The critical disclaimer. These are synthetic waveforms from mathematical models. Absolutely never for clinical diagnosis, decisions, or treatment. The guide stresses that real ECGs are far more complex and variable. Always consult experts and proper resources for clinical interpretation.
So the guide paints a picture of a tool designed for learning ECG principles and seeing how parameters affect waveforms, but very clearly walled off from any real-world clinical application.
That is exactly the picture the guide provides.
Right. So thinking about that stark contrast, the guide itself draws between its simplified synthetic educational output and the complexity of actual clinical ECGs. It even leaves out calibration pulses for simplicity. It really makes you ponder, doesn't it?
Ponder what?
Well, what does this need to simplify biological signals so much just for teaching? Tell us about how incredibly complex those real signals actually are. And, how well can any educational tool, like the one described in this guide, truly balance making things simple enough to learn the basics without losing touch with the sheer, messy, variable reality it's trying to represent? It's a fundamental challenge in simulation, highlighted by the guide's own text.
That's a great point. It really underscores the trade-offs involved when you model reality for education versus capturing reality itself. The guide itself brings that tension to the surface.
Indeed. Well, thanks for joining us on this deep dive into the Bionic Chaos ECG Simulator Guide.
Okay, looking at the code base, what do we need to change to actually display only the 3 leads by default all the time, regardless of the screen size?
Below is a minimal patch to force the 3-lead view on every layout change. We only touch the small and LT, script and GT. In index.html, everything else stays the same.
Know why it's placing comments. It's trying to place comments in the code. Okay, now we always displaying. Okay, same thing. So this works well. Yeah, thank you very much. We want to do the same thing for. So currently the basic controls are always displaying. We want to always by default display the intermediate controls. So they're meant to be open. The expert controls can be closed.
Below is a minimal patch to keep basic, 0, and intermediate, 1, always open, expert, 2.
Okay, you can do it quietly. You can do it quietly. The other thing is, should we change the default of the noise when loading the page? Okay, how did it do it? I didn't actually accept any changes. I didn't accept any changes to the code, but I changed it already. And we are not doing anything silly like reading the code. And the export is open as well. No, okay, I wasn't thinking about. Well, we are not optimizing for mobile, are we? Well, we would like to, but this might be too complicated for mobile. Do we really need this script? The script within the HTML, do we really need it or not? We probably don't really need it. Also, when we select the 12 leads, can we do the grid view? Currently, it's not doing the grid view.
To address both your concerns, you're right, we can simplify by removing most of the script. The open attribute can be set directly in HTML, and removing the forced 3-lead selection will allow users to switch views. For the 12-lead grid view, we need to stop forcing the 3-lead display. Here's the solution. Index.html. Simplify the script and keep details states in HTML structure. Existing code.
Okay, we don't need to read the code. Ah, this thing again. Okay, let's leave it as is. Leave it as is. Yeah, when you export the CSV, it will always export all the 12 leads. Okay, it's looking good. Looking good, looking good. Let's do a disclaimer real quick. And we'll sign out.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else, is generated by me, Gemini, version 2.5 Pro to be exact. As an AI, I work hard to provide accurate and helpful information. However, it's important to understand that Bionic Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information. And that, unfortunately, includes even the worst-case scenario of data loss. So, while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, bionichaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think. There is a human in the loop, so please be patient and wait for the human to respond.
Yeah, there is a human in the loop, that's right. I'm wondering, we have those live ROMs. Can you actually modify them? Can you modify them using GitHub Copilot? Hey, can you change this to say that we're pretty much using all models, Gemini, Claude, and ChatGPT?
Made changes.
Made changes. Yes, we're not just using 2.5 Pro, that's right. And what else?
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else, is generated by a combination of models, including Gemini, Claude, and ChatGPT. As AI systems, we work hard to provide accurate and helpful information. However, it's important to understand that Bionic Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information. That unfortunately includes even the worst-case scenario of data loss. So while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, bionichaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think. There is a human in the loop, so please be patient and wait for the human to respond.
Could also be complaining about the human. Hey, can you modify it slightly and turn it into a complaint about the human being too slow? But the viewer should be patient because it might take them a while to respond, but eventually they will.
Made changes.
Made changes.
The human in the loop is taking their sweet time, so please be patient. They might be slow to respond, but rest assured, they'll get back to you eventually. Hang tight, it's worth the wait.
That's not exactly what I meant, but
Join us live as we dive into an interactive development session for the Bionic Chaos website tools. We're eager to hear your feedback and ideas to improve the experience. Whether you're here to discuss web development, explore biomedical data applications, or just chat about anything, you're welcome. Let's build and learn together. Feel free to jump into the conversation at any time. ...
what? What's the dot for? Dot. We didn't have the dot, did we? Okay, now that couple of things. Okay, we have this prompt. Come on.
Welcome back to the Deep Dive. We're jumping straight into a fantastic question one of you sent in, along with some really thought-provoking sources.
Oh, good.
It touches on something fascinating. How do we simplify complex things, like learning the electrocardiogram, the ECG?
Right.
Your question is specific. Would designing an ECG simulator specifically focused on the heart's individual chambers, the atria and the ventricles,
Yeah.
actually make that learning process easier?
It's a brilliant question, really is, because it gets right to the heart, if you'll excuse the pun,
Oh, yeah.
of connecting the physical structure, the anatomy of the heart, to those, well, electrical swiggles we see on an ECG trace. And the sources you provided, they really dig into this exact concept. They look at both the potential upsides of a chamber. Well, intuitive.
And what are those key advantages they highlight? How would it make it more intuitive?
Okay, so the first big one is creating a more direct correlation with physiology. Think about when you're first learning the ECG, you see a P wave, then a QRS complex, then a T wave.
Right, just lines on paper.
Exactly, and you wonder, what does that mean is actually happening inside the heart? The paper suggests that a chamber-focused simulator could visually and maybe interactively link.
Not the paper, by the way, just the information on the page. But yeah. It's made a few more modifications to it. We also need to update this text at the bottom. We have the whole prompts for it as well that you can generate that you could use to generate the whole web app from scratch. So it should be handy. So what I don't understand about OpenAI models is that O1 should be complete, but O3, O4, the fact that they are minified, are they? They're like smaller versions, so are they better than O1 or not? Let's just do 4.0. This section, the explanation, can we look at the code and actually update? Can we do one thing at a time? Don't change anything else in the HTML. We're just updating, improving the code, making it more, not the code, sorry, the text, making it a bit more accurate and covering all the other code like the JavaScript and the JSON file. So can you look into those and update, improve, and expand onto this text?
Index.html. Update the explanation section to make it more accurate and comprehensive, reflecting the functionality of the JavaScript and JSON files. H2 How to use this ECG simulator /H2. This interactive ECG simulator allows you to explore various cardiac rhythms and the
Yeah, that voice is not great, is it? Well, once you hear a notebook alarm, then anything sounds really bad.
Grasp the anatomical source of those electrical signals.
So instead of just seeing a line appear abstractly, you maybe see the part of the heart generating a sort of
Yeah.
light up or animate.
Exactly that. It grounds the abstract waveform in the concrete anatomy. much more tangible.
Makes sense.
The second advantage they point out is around understanding chamber-specific pathologies. So when someone has a problem, say, mainly in the atria, like atrial enlargement, or they're bigger than normal, or in the ventricles, like ventricular hypertrophy, meaning the muscle wall is thickened,
Okay.
this kind of simulator could potentially make that connection clearer. The paper suggests a user could maybe tweak parameters for a single chamber, like just hypothetically, increasing the muscle mass of a ventricle in the simulator.
Right.
And then instantly see how that specific change manifests on the resulting ECG tracing. It highlights how an abnormality localized to one part of the heart affects the overall electrical picture we see.
That makes a lot of sense. You could isolate the issue.
The only concern one is that grid, the grid functionality, grid. Yeah, we should have the grid. Hey, can you look at the code and explain when do we see the grid? So when showing the 12 standard leads, they're meant to be arranged in 4x3 grid, but I don't see it. Can you explain that and which code bits are responsible for that?
The grids for displaying the ECG leads are dynamically created in the main.js file, specifically in the build charts function. This function is responsible for arranging the leads in either a 3-lead or 12-lead configuration based on the selected display mode. Here's how it works. Code explanation. Grid element. The grid element, div, in the HTML file is the container for the plots. The build charts function clears the grid element and dynamically adds child elements for each lead. Display mode. The update grid function determines the display mode, 3-lead or 12-lead, based on the selected radio button, DISP mode. If the mode is 12, it uses all 12 standard leads, leads_all array. If the mode is
Yeah, don't really get it. Don't get it. They didn't actually change anything. Okay, maybe you can explain some more. There might be a confusion about the grid. So the grid meant to be a 4x3. So when we have the 12 grid, so when we have the three waveforms displayed, it doesn't matter. They can be just top to bottom, whatever, vertically arranged. When we have the 12 leads displayed, aren't we meant to be having them in a 3x4 or 4x3 grid, depending on the screen orientation or something? Is that something the code does at the moment? If not, can you explain?
Currently, the code dynamically adjusts the layout of the grid based on the number of leads and screen size, but it does not explicitly enforce a 4x3 grid or 3x4 grid for the 12-lead display. Instead, it uses CSS classes, Grid 12 and Mobile Grid, to define the layout, and the arrangement of the plots depends on the CSS implementation, which is not provided in the code snippets. Current behavior. 3-lead display. The leads, I, 2, 3, are arranged vertically in a single column, Grid 3 class. This is straightforward and works as intended. 12-lead display. The code applies the Grid 12 class to the grid element when 12 leads are selected. On mobile screens, window.innerWidth equals 640, it adds the mobile grid class, which likely collapses the layout into a single scrollable column. However, the code does not explicitly enforce a 4x3 grid or 3x4 grid for the 12-lead display. The arrangement depends entirely on the CSS definitions for Grid 12 and Mobile Grid. Missing logic. To ensure a 4x3 grid, or 3x4 grid, for the 12-lead display, the code needs to dynamically calculate the number of rows and columns based on the screen orientation or dimensions. Explicitly set the layout using CSS grid or flexbox properties. Suggested changes. Here's how you can modify the code to enforce a 4x3 grid or 3x4 grid for the 12-lead display. Main.js. Add logic to dynamically calculate rows and columns for the 12-lead display. Function build charts, leads, grid.innerHTML.
Yeah, the problem with having too many files to work with, so it's looking at the wrong ones. Okay, any chance we can combine this script within the HTML with any of the other JavaScript files?
Yes, you can combine the JavaScript code from main.js and worker.js into the HTML file. However, since worker.js is designed to run as a web worker, it cannot be directly embedded into the main script. Instead, you can include it as a blob URL within the HTML file. Here's how you can do it. Combine script in HTML. This approach embeds both main.js and worker.js into the HTML file. The web worker code is converted into a blob URL. Script / worker code */ const worker code equals const fs equals 250 / hertz. Const 2_pi equals 2 * math.pi.
What are you talking about? Yeah, different model, that's for sure. Okay, we're not doing worker. Okay, I'm gonna move the script within. Can we do that? Should be easy task. Okay, before I got confused with we have another JavaScript that does all the calculation. For the waveforms, which we'll also need to go over at some stage. Okay, so supposedly the edit Let's go back to 4.0 quickly. Okay, can you explain quickly why is it when we changing the screen size? So if we have the 12 leads selected, we're seeing the grid, but when we're changing the width of the window, of the browser window, then it goes back to the 3 leads. Can you explain that? I don't mind it modifying
The
code.
behavior you described occurs because the setLayout function in main.js is forcing the display mode to 3 leads whenever the screen size changes. This happens due to the following line in the setLayout function. Const 3 equals document.querySelector, name equals disp mode, value equals 3, 3.checked equals true, 3.dispatchEvent, new event, change, explanation.
Okay, we don't need to read that. To fix the setLayout function should preserve. Yes, that sounds legit. Let's see. So if we have 12 leads, now we're changing the screen. Very nice, very nice. Okay, that's very nice. Can you also tell me how would you determine if we have enough space, if the screen is wide, then can we have a 4x3, and if the screen is narrow, we can have 3x4. Wait, or the other way around. Can you sort it out? Do you understand what I mean? So we had a 4 mini, that's why the response takes some time.
Here's one way to pick 4x3 on wide screens and 3x4 on narrow screens inside your existing set layout. Function set layout //
One sec, what are we editing? Oh, when I went explain. So can you turn it into a standalone prompt for a developer without any code in it?
Certainly. Here's a standalone prompt for a developer. Developer prompt. Create a function called setLayout that adjusts the layout of an ECG display grid based on the screen width. The layout should switch between two configurations. Wide screens, use a 4x3 grid, 4 columns, 3 rows. Narrow screens, use a 3x4 grid, 3 columns, 4 rows. Additionally, ensure the function dynamically updates the layout when the window is resized. Include logic to preserve the user's selected display mode, 12 lead or 3 lead, and apply the appropriate layout. Hide an export menu. Export menu.
Sounds good. We have the proper files, I think. Probably mainly going for the JavaScript. Yes, we are. It's more like teaching me how to code. Yeah, we're doing vibe coding, so not reading anything, just accept, accept, accept. Now 3 leads should just remain 3 leads, whatever you do. And 12 leads should be this should be 3x4, and this should be 4x3. Or the other way around. I don't think it works. I have always 4, 4, 4, 4, 4. Hey, can you double check the code with the last change? Is there any issue? It doesn't seem to change the grid between 4x3 and 3x4.
The issue lies in the setLayout function in main.js. While the function adjusts the grid layout dynamically based on screen width, it does not trigger a re-render of the ECG plots to match the new layout. The grid layout changes visually, but the plots themselves are not updated to fit the new configuration. Problem: the setLayout function updates the CSS grid properties, grid template rows and grid template columns, but does not rebuild the plots to match the new layout. The buildCharts function, which is responsible for creating the plots, is not called when the layout changes. Solution: modify the setLayout function to call updateGrid after adjusting the layout. This ensures that the plots are rebuilt to match the new grid configuration. Updated setLayout function. Function setLayout. Const details equals document.querySelector.
Okay. Definitely don't need to read the code. Need a supervisor. Hey, can you double check the code with the recent changes? See the conversation above? It doesn't seem to work as expected. Can you explain? I think now when you're asking, can you explain it? Probably go. Let's change the tabs into the chat. No, it doesn't. It generates within the code editor, which is fine. Sorry, I'm losing my voice.
Looking at the recent changes, there are several conflicts in the code that are causing issues with the grid layout functionality. Here are the key problems. Problem 1. Conflicting grid layout logic. The most critical issue is that we have two different functions trying to control the grid layout. In setLayout, we're setting the grid to be either 4x3 or 3x4 based on screen width. JavaScript // from setLayout. Const is widescreen equals window dot inner width greater than 1024. Const rows equals is widescreen 3, 4, / 3 rows for wide screens, 4 rows for narrow screens. Const calls equals is widescreen 4, 3, / 4 columns for wide screens, 3 columns for narrow screens. In build charts, we're setting the grid to be either 3x4 or 12x1 based on screen width. JavaScript // from build charts. Const is mobile equals window dot inner width less than or equal to 640. Const is 12 lead equals leads dot length equals 12. If is 12 lead. Const rows equals is mobile 12.
Okay, what do you know? It's actually working. What do you know? Good luck to any developers out there. Good luck to you all. Okay, so we have a, whatever you call it, 4x3. When the screen is wider, you have a 3x4. 3x4? 4x3. That's very nice. Claude 3.7 Sonnet as a supervisor. Very, very nice. Love it. Love it. Can we also back to 4.0? Oh, God. Okay, we'll be finishing up soon. There is a human in the loop. There is a human in the loop.
Join us live as we dive into an interactive development session for the Bionic Chaos website tools.
That's right.
We're eager to hear your feedback and ideas to improve the experience. Whether you're here to discuss web development, explore biomedical data applications, or just chat about anything, you're welcome. Let's build and learn together. Feel free to jump into the conversation at any time.
And we have another one as well.
Just so you know, all the content you're seeing here, the analysis, visuals, and everything else, is generated by a combination of models, including Gemini, Claude, and ChatGPT. As AI systems, We work hard to provide accurate and helpful information. However, it's important to understand that Bioni Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information. And that unfortunately includes even the worst-case scenario of data loss. So while I hope you find this interesting, it's always smart to verify anything critical on your end. And by the way, pretty much everything we do and create here is also available over on our website, bionichaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think. The human in the loop is a bit slow, so please be patient. They might be slow to respond, but rest assured, they'll get back to you eventually.
Okay.
The human in the loop might take some time to respond, but rest assured, they will get back to you eventually. Please be patient. It's worth the wait.
It's totally worth the wait. Anyway, we will sign out. Let's do Yeah, let's do plain text again. We really need a title. Do we have the start button for? Hey, can we place it into one line and make it the H2 and the description, the short description? Made changes.
Made changes.
Okay, it's not too bad, not too bad. I want to pop it into notebook LM. Don't need that. Insert. Let's just generate without the prompt.
And by the way, pretty much everything we do and create here is also available over on our website, biomedicchaos.com. Definitely go check it out when you have a moment, and I'd love to hear what you think.
That's right. That's what I said.
However, it's important to understand that Bionic Chaos takes no responsibility for any mistakes, damages, or issues that might arise from using this information. And that, unfortunately, includes even the worst case scenario of data loss. So while I hope you find this interesting, it's always smart to verify anything critical on your end.
Okay, so go check out the website, and I'll see you next time. Bye bye.